Good morning, good afternoon, good evening. This is Dr. Garais for MED210 5DAX, and I'm going to make a quick video lecture regarding the week 7 notes. The videos for this week are pretty good, um, but I got some stuff and some clarifications, and that's why I created this sensory. Let me open it up. Let's see if we can actually. It's got some pictures in it. Let me see if the pictures downloaded. Just checking. I don't think so. Well, not here, but I have Microsoft Word online. But I'm just going to go over some items that will tie all of this together. So when we're thinking of sensory, let me clear this. When we're thinking of sensory, let's look at homeostasis for a second. And this thing that maybe you've seen in anatomy and physiology, anatomy and physiology 1, you probably saw this drawing before. Right? This is essentially what happens to your entire body to keep you stable. Homeo means same, stasis means to stand in one place. So pop-ups are annoying, yes they are. Okay, so when you look at it, if you recall, I believe it was the last chapter of Anatomy Physiology 1, there has to be some stimulus, there has to be some signal from the outside world telling you that there's an imbalance, there's something wrong. And who picks up that stimulus? A receptor. So that's what this whole entire chapter is about this part of homeostasis, which is there has to be some sort of like camera or sensor to pick up that something's wrong. Then it goes through an ascending tract, also known as the afferent, A-F-F-E-R-E-N-T pathway, which is the sensory pathway, to the control center, which is of course your brain. The control center then takes that information, and then you have a descending or efferent, E-F-F-E-N-T, E-F-F-E-R-E-N-T, sorry, can't spell, and that'll affect an effector, most likely a motor pathway. So you have the motor pathway here, which is the response, and you have the sensory pathway, and that's what we're talking about this week, the sensory pathway, okay? And you need, of course, a sensory for to sense that things are in danger, something's wrong, and not all of it is part of your conscious body. Like there are times where you feel cold and you don't really even notice it. There's a whole bunch of things that you don't really notice. Like right now, I've been sitting on this chair for, I don't know, 4 hours or so. And it's not quite a comfortable chair, but I haven't noticed it. Now I notice it because now I'm drawing attention to it. So another concept is this concept of transduction. Your eyes don't really see anything. The sensors just pick up data, or they pick up energy, right? And let's talk about this word transduction. It's the conversion of energy into signals the brain can understand. The brain can only understand chemicals and electricity. We already know that from the nervous system. So all your eyes are really doing is taking light waves and changing them into signals in your sensory pathway, also known as your afferent pathway, to something that your brain understands. So when you're looking at things, hearing things, tasting things, that is your brain's interpretation of sight, sound, and all of these things around you. So it's a little trippy. It's a little bit like The Matrix, with Keanu Reeves, but you're not really seeing things. The things that you're seeing, the screen you're seeing, the voice you're hearing, it's not really me. It's your brain's interpretation of me. So that's what I like about this particular chapter. It's pretty trippy, because it now makes you realize and makes you question a lot of things, and also you can easily see how mental illness is a biochemical, chemical, physical thing, right? Because if your brain is not properly processing all the transduction or all the energy that's coming in, can you easily think that it's hot when it's cold? Can you easily start seeing things? And think about all the times you've been tired. Um, uh, you ever seen something at the corner of your eye? Or those of you who have children or have loved ones, which is hopefully all of you, being separated from them, don't you hear their voice every once in a while, right? But you're not crazy, right? Also, the same thing about memory. There are some things that we remember that were gosh awful, and there's some things that we remember that were really great. Like I always, if you always ask me, I always my memories, right, or my interpretations, my brain interpretation of high school was great. But when you really come to think about it, is high school really great? You're not a child, you're not an adult, you got to go to work, but you don't get paid much, and there's just a lot of pressure in high school, and things of that nature. To go to a good school and all that. Don't do drugs. Don't drink. But you want to drink, or your friends want you to drink. So you could see how transduction, it's just energy, but it's the brain that does the interpreting. Now, the thing you got to know about each sensory part is you have to think about the modality. What is the type of energy? Like for eyes, we already talked about, is light waves, right? So the modality, or the type of energy, this type of stimulus that will go for the brain has to be light waves. And your retina picks up light waves, and that's the receptor. And then they put it through a wire called your retina, and then your retina brings it up to your brain, and then your brain interprets what it sees. That's why magic tricks are so neat, because they utilize actually the physiology of how your brain works and how your eyes work, right? Sound waves as well, transduction or the conversion of mechanical energy, and we're going to be talking about that. How there are these little bones in your head, and they are called ossicles. They're the smallest bones in your body, and when you hear something, these sound waves, which is energy, it gets transduced into electrical via chemical, mechanical, and we're going to talk about that, how that mechanical energy hits your tympanic membrane, hits your ossicles. Your tympanic membrane is your eardrum, hits your ossicles, and then the cochlea has hair cells in it, and then that's what does the interpretation. I mean, not the interpretation, but sends the signals, the electrochemical signals up until your cranial nerve 8, vestibulocochlear nerve, and up into your brain. Now, intensity. If there's more firing of the or more electrical signals, right, then it'll be louder or softer, right? So the louder the signal, the higher the intensity, the more nerve fibers are activated, and that's intensity. And duration, I already talked about sensory adaptation, is like right now, my chair underneath my gluteal muscles, it's starting to bother me because I'm now noticing it. So you have your general senses. Um, uh, Look them. It's part of the video. I put them in here. Somatosensory. So somato, your body, your pain, your nociceptors, and they also deal with chemicals and neurotransmitters such as substance P, serotonin, and enkephalins. And regarding heat, cold, and pain, look up first versus second order versus third order. I believe it's in the videos, and if not, you can Google it. And if you recall the myelin sheath, right? What does that do for the saltatory conduction, and what does that do for the speed at which the signal is sent out. And, of course, all the other special senses, which is hearing, visual, taste, and smell. Taste, look at, it's of course cranial nerve 9, glossopharyngeal. Glosso meaning your tongue, pharynx, of course, your throat. And in real life, it's a combination of 7, 9, 10, but 9 is the main sensory. Again, back to know what's transduced, what kind of energy that your sensor picks up, know what the sensor is, and then know what the nerve that's carrying it to the brain. So for taste, the sensory are hair cells, and these hair cells require water solution or an aqueous solution. Now, here is cranial nerve 1, olfactory nerve, the cribriform plate. Oh, my cocaine story. Okay, so how you could see right now, let's look at the cribriform plate. And this is something I was talking about, you know, if we were on the ground. You guys who've had me before know I like to tell a lot of clinical stories. But let's look at here. The cribriform plate houses, it's right here, and this is your nose and your nostrils. Let's see if we can get this picture. Okay. There. So here's the cribriform plate. You see it's very, very thin, and it's got spaces. And it goes, and this is your brain, and this is your olfactory tract, and your cranial nerve that goes, and of course this is your brain. You could easily see how chemicals can go in here, and then can go right up in there. And that's why you get the effects of drugs that are inhaled or snorted very, very easily. Okay. Now, olfactory bulb, olfactory nerve. Now, like, what are hair cells? And that's a recurring theme in sensory organs, in your nose, in your mouth, and this is your ear. So let's look at hair cells. Let's look at what a hair cell does. Let's see a nice picture of it. Okay, here's it. So you look at a hair cell, and it's got these things called stereocilia on it, and like when you move them, right, it's going to send electrical signals based on the movement. Now there are also other hair cells that also react to chemicals, and that's the ones in your nose, and that's the ones on your tongue. So if a certain chemical gets on here, then it'll send a signal, and then you have what? You have your afferent pick up, what do you call that? Pick up the signals and send it to the brain. Okay, and of course you have an efferent nerve ending. Okay, right? Because wherever you have a sensory going up into the brain, you have a descending tract that goes down as a form of effector, or like a motor. That's the word I'm looking for, a motor response. All right, so let's look at hearing and equilibrium. And all of this is in notes, but if you look at the actual Microsoft Word document, there's pictures in it. I'm curious, where are my pictures? Oh, well, because since it's just preview mode, it doesn't, it doesn't show all the pictures. So let's look at hearing and equilibrium. Here's a pretty picture. Look at this one. So hearing and equilibrium go hand in hand. And those of you who've had some inner ear or middle ear problems, you know that dizziness also comes with any hearing loss, with certain hearing loss. So let's look at how typically sound is transduced. Now this is called your pinna, this whole entire thing, which is part of your auricle, helix, and lobule. It serves no real purpose. Its only real cool function is to hold your earrings or hold your glasses up. It is the auditory canal that's important. It takes all the sound waves and funnels it down here into your tympanic membrane or your eardrum. The eardrum, like if you've ever like talked or yelled into a snare drum, and the snare drum starts rattling, right? Well, when you speak, when you hear things, this starts to shake. And that mechanical energy then goes to the ossicles, the smallest bones in your body. Malleus, incus, and stapes. Malleus stands for the hammer, incus is the anvil, and stapes is stirrups. Because whoever checked them out thought, hey, that's what it looked like. It looked like a hammer, anvil, and stirrups. But just know them as the ossicles, malleus, incus, and stapes. And they're connected to your tympanic membrane. And then when you hear things, this all shakes. And then it goes through this oval window here and then goes through your cochlea. Now, inside your cochlea is a whole bunch of hair cells. Now, the hair cells are all surrounded by this fluid called endolymph. So when that mechanical energy starts hitting that water, you also know if you look at water that's still, yell at it. The water will start to move, right? Will vibrate a little bit. Well, those either small or large vibrations get into the cochlea. The cochlea then does what? Transduces the sound waves into electrical impulses, which the vestibular cochlear nerve can handle. And the cranial nerve 8, the vestibular cochlear nerve, is a combined nerve. So you have the cochlear part doing the hearing and the vestibular part doing the balance. Now, where does balance come into play here? If you see these semicircular ducts, they're configured in like three-dimensional hoops. If you look at it, one hoop's going like front to back, the other one's going sideways, and the other one's going diagonal. If you could use your imagination a little bit. But think about if those had hair cells in it, which they do, and it has endolymph. So when you turn your head to the left, all the water is going to go where? To the left. If you're hung upside down, all the water is going to go where? To the top, and it'll send signals that you're upside down. Now, think about when you're mentally or physically impaired when you drink too much alcohol. What happens? Right? For those of you binge alcoholics in the room, myself included, all right? You ever, like, when you're really, really drunk, like, you move your head, and then a second, like, the whole room is spinning, and then a second later, the room will spin in the direction of your head, but it happens all so late? Well, the sensory is what? It's still picking up the signals of what's going on, but the signals to the vestibular nerve are impaired, and of course, the brain part that will pick up the vestibular nerve is also impaired. And your ear is, of course, separated in outer, middle, and inner ear. The outer ear is from the tympanic membrane on out. The middle ear is from the tympanic membrane to the oval window. And then your inner ear, which has all the neurosensory parts. Yellow for, of course, nerve. It's the vestibulocochlear nerve. That's the inner ear. Another thing that that your ear has right here, right? I don't know why they call it the auditory tube. That's your eustachian tube. Now, your eustachian tube, that's the thing that, you know, when your ears pop, it's the function of the eustachian tube is it connects the pharyngeal area of your throat to your middle ear, middle and inner ear to be exact. And it's supposed to equalize the pressures. And that's what happens when, you know, you go up into the air, you know, you go up very, very high or or very, very deep in the water, that's why you feel your ears pop, and it's because of this eustachian tube. Okay? So that's hearing. So let's look at vision. And again, there's a nice little video and shows that, but oh, here's another better view of the vestibular apparatus, or the thing that provides balance. Do you see that one's going this way, the other one's going another way, and another one's going another way? So it provides data on 3 dimensions. So that's why if your head's to the left, or even I could put you even in a dark box, and then I'll turn the box on its side, you kind of know that you're on your side, or you kind of know that you're upside down, and it's because of the endolymph and the hair cells. So let us now go. How about this? I just close this. And now let's go through eyeball anatomy. Nice picture. And I believe these are very, very similar, or if not the same exact pictures that I chose for the notes. Okay, so let's look at this. And remember, the transduction that's going on regarding your vision is you're taking in light rays, it's going into your retina, right? And where's your retina? See this yellow thing? And of course it's a yellow thing because it's a nerve, okay? And the retina also has rods and cones, and that's what these cells look like. They're rods because they look like rods, cones because they look like cones. And the rods deal with night vision and visual acuity, and the cones deal with day vision, right? And or colors, your ability to see colors. So if you look at all the parts of the eye, their function is to bend light, and the word for bending light is refraction. Refraction is like, you know, when you look at a fish in a if any of you ever had goldfish or fish, then you try to catch the goldfish, but it looks like it's one place in the bowl, but it's really like an inch or two over when you stick your hand in it. And you notice when you stick your hand gets all distorted because of the water. That's refraction, right? Now, on a normal eye, all of these things are clear. So you have a jelly-like substance here in the posterior portion of the eye called your vitreous humor, right here. And then in the anterior portion of the eye here, that is your aqueous humor, which is filled with water. And again, water and oil, or water and jelly, have 2 different refraction rates. And the function of all of that is to do what? Steer the majority of all the light rays, or the light waves, into the retina. Now, you have a lens here. You have a pupil that's connected to this ciliary body that opens and closes the aperture or opening here like a camera. And you have ciliary muscles here that also control the lens. Because if some of you, whoever played with a what's it called, a magnifying glass, you notice if you can tilt the magnifying glass or a certain way, the light would bend, and sometimes you'd get a nice concentration of light, and then that would like burn your hand, or maybe you burn some ants. I don't know, but students always look at me weird when I used to say stuff like that in class. I was a strange child, but that's what that does. The lens as well tries to focus everything into the retina. Okay, a cornea is a nice protective shell, and of course that has to be see-through. Iris is the coloration of the surrounding material of your eye, and it's based on pigment, melanin, right? So if you're from a place closer to the equator, you're going to have more melanin in order to protect your eyes from UV radiation. And if you have blue eyes or light gray eyes, you don't need that much melanin because your genetics are from a place that, like maybe in the North Pole or something, or in Scandinavia, where you don't require that much UV protection, versus people who have their genetics closer to the equator of the Earth, where there's a lovely abundance of UV radiation. So with that being said, all of that gets into the retina. And you could see how diabetes, cataracts, if you scratched your cornea, or if anything happens to any of these muscles. And of course, for vision, if anything happens to the shape of, especially of your eyeball, how it can screw up with getting all the light waves to the retina. And if not all the light waves get to the retina, then the signals going to your brain will be not optimal for vision. Okay, and that's why we have glasses, so we can correct that. Right, that's why we have surgery, so we can go fix the shape of your eye. And when your eye gets a little like misshapen, like more like an egg and less like a, I don't know, less like a bowling ball, that's called astigmatism, and that too can mess up your vision. Now, if you see the macula densa here, there's like a blind spot. And you're like, okay, when I open both of my eyes, or even when I close one eye, I don't see any blind spot. Well, there's a blind spot. Think of it this way. The retina, the rods and cones are all cameras, and they're all connected to wires. Now, the wires got to go somewhere. So all of it goes into your optic nerve, but all the wires have to converge on one place. So there can't be cameras everywhere. So the one place that they converge on, in order to go to the optic nerve, there are no cameras, hence the blind spot. But the neat part is both your eyes, right, are looking at the same direction at the same time. So the other eye is seeing the part that the blind spot missed. And remember, you're not really seeing anything. Who sees everything? It goes, who actually interprets what you see? It's your brain. That's why you don't see any blind spots, right? Because the brain filled in the picture. Okay? All right? And that's vision. Okay, let's see if I missed anything else. So we talked about light and vision, hearing and equilibrium. Oh, the fovea centralis. I forgot to mention that as the blind spot. Cilia bobbies, rods, cones. I mentioned that part. Color vision. Okay, so overall, I think that's all we have for special senses for this week. If any questions, comments, or recipes, please give me a call. And please, this is week 7. Do not forget to register. I already put out some instructions on how to register, so please do so. Please do not wait, because by the beginning of next week, they're going to start canceling low enrollment classes. And then they'll kill a class, and then if not enough people sign up for it, and then they get rid of the class for for efficiency reasons. So please, the earlier you register, then the classes won't cut, especially if it's one of my classes. I would love to have you guys in my other classes, but odds are most of you already took my class. So, but there's others, so that'll be good. Now, of course, kindly do your task. Make sure it is really in the form. I'm really buckling down now. Many of you keep on giving me notes, but I'm really buckling down. It really should be on in a what's the word I'm looking for? In a I keep on calling it mind map because my daughter keeps on calling it that, but concept map format. Okay, and let's look here. Let's look at some week 7 stuff to make sure we're at. But that's the supplementary lecture, because remember, even though you hand in all your stuff, you got to learn this stuff because You're going to be in pathology. You're going to be in all these other classes that require your knowledge of the anatomy and physiology. So let's look at task 7. Communication, special senses, communication via the sensory system. And so when you look at this, you watch all the videos. Nice, nice, nice. Taste and smell. Now, design a concept map. Yes, that's what they're called. Structure and function of eye, structure of ear, tongue, taste, structure, function of your olfactory, which is nose and smell. And remember, olfactory and gustatory, which is taste and smell, they're both related. They're both hair cells. You need one to utilize the other. Try eating your favorite meal when you have a stuffed nose. It's really hard to do. And or try doing that when uh, 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 when you're when your mouth is all gummed up. Like for example, how does crackers taste if you eat too many of them? Right, you barely can taste anything. Right? Or maybe you can barely just taste the salt. Right? So again, also has to be an aqueous solution. So we went over all of that and just break those down. The special senses lab, again, in real on the ground class, we would have done the lab, but there are nice notes in here if you see here, and they mirror the items that I was talking about. And there's yet another picture and stuff like that. But again, you don't like that picture? Use another one. Ooh, reflexes. Ooh, I'm not sure if I was supposed to mention it here, but heck, since I saw that, let me mention it. Now, it's a diagram of a reflex. So let's look at the reflex arc. This is a nice picture. Yes, it's a side note. Oh, dang you, Pinterest. I freaking hate Pinterest. Always making me see, and then I gotta sign in, and ugh. All right, might as well use this. Now, typically, we showed you the arc of the entire sensory and motor reaction. And that was the picture that we showed you, the one with the seesaw and the man. So that is when, that happens too, when you prick your finger, or I was making french fries yesterday and I got oil on my hand, right? The reflex arc is a protective function because there are sometimes we need the signal to go through the sensory, right, and to the motor a lot quicker. And it's usually happens in like moments of danger, right, or danger to the human body. So one of those things are like if you get hurt, right, nociceptors, right, or and like my example, when you burn your hand. Now, typically it would go all the way up to the brain and then go all the way down the spinal cord and go back, and it does. But there's a shortcut, and that's the reflex arc. So the reflex arc does not require brain. But what does it require? It requires an intact sensory, right, also known as afferent, A-F-F-E-R-E-N-T, pathway. And then in your spinal cord, you have your interneuron. That's that green thing right here. And then you have your descending tract, which is your motor that'll make you do what? Pull your hand away if the stimulus is painful or dangerous, right? Now, this reflex arc also shows you that this is the reason why yesterday when I was cooking French fries, that I was able to pull my arm away even before I felt the pain. And how does that work? Because the reflex arc, it had to travel from here, 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 and get me out of danger, right? And then the rest of the signal went all the way up to the brain and then went back down. So that's why a couple of milliseconds after I saw the oil or kind of felt the oil starting to burn on my hand, I already had my hand, and also you'll notice the majority part of your body already away from the danger. And that's a reflex. And the reflex here that they were talking about in these notes is pupillary reflex. Because, if something's too bright, your pupils have to do what? Have to constrict. If something, if it's too dark, the pupils then have to do the exact opposite and then open up, right? So that you could see everything you need to see. What else is in these notes? Maybe something I missed. Snellen eye chart, you'll learn that in your clinical classes. Stigmatism I mentioned, rods, cones, fovea centralis, optic disc, optic nerve. We already mentioned that in the notes. Visual field, hearing. Yeah, I think I touched on all the major items. So from this lecture and from the videos, just make a concept map. And the first part of the concept map is special senses. And then one will be the eye. Then the other circle will be ear. The other circle would be taste, and the other one would be smell. And then what can attach to each one of those? What's the transduction? What is the energy? The other one, what is the nerve that's it's associated with? And lastly, what are the parts? How does it work? Okay, so you look at it, it's pretty straightforward. Okay, and again, I'll be accepting late, but come on, this is due next week. Should be due. Well, actually, it was due today, and look at it. We only have like one person, but try to get it out. You guys know I'm very good. I'm very lax with grading, especially in this atmosphere of quarantine online learning. Which, by the way, will continue to, as far as my knowledge currently, to task 3. Not task 3, term 3. So let's look at... Oh, now that I mentioned this chair, it's now killing my back. Let's look at... Oops. Let's look at lesson 7. Hello, thank you. All right, activity 1, activity 2. Okay, eye dissection, we're not gonna do. Group discussion and concept map, not gonna do. What do we always do? We always click on the case, right? Once we have the case, we always click on the upper right hand, usually a green box that says download case. That's if it's working. And then we'll look through the case and answer it and submit it in a Microsoft Word document. Now, typically, if we were on the ground, we'd do this all together. But not on the ground. Oh, Snapple. Didn't even notice they have answer keys and teaching notes. Come on, people. I think they're giving you this stuff right there, unless that's not related. Hearing loss, right? Introduction, of course, in the case. Part 1 is always the introduction. And then the questions, answer those questions. Part 2, the checkup, and then answer those questions. I think part 1, part 2, you're good to go. Okay? All right, with that being said, please get this out to me. Don't fall behind. You don't want to repeat this. And for you nursing candidates, you got to get at least a B-. Come on now, that's doable. Let's look at discussion, see if I can give you some hints on that one. The discussion for this week. Again, back to my constant commercial. If you have a 0, it will remain a 0 if you do nothing about it. But if you go and do it and get some partial credit, make sure if you're already awarded a 0, please email me or text me via Moodle, right? That, hey, Dr. Garais, can you look at my last week's submission? I was late on it, So can you please look at it? Because it's week 7. It's like 3 more weeks. Right? You don't want to be that person trying to do 4 discussions in the last weekend. All right, thank you, Ms. Hudson, for getting that to us. All right. Looks like I already replied. Sensory changes can affect an individual's lifestyle, whether they're due to aging, birth defects, or injury. They may have problems communicating with others, engaging activities, and feeling a part with what's going around them, just like the case. Investigate new technologies, by new, sometime this year, 2020, right? And how they're going to affect somebody's life. Pictures, references, and make sure it's APA formatted. Alrighty? Okay, with that being said, that is week 7 in a nutshell. Thank you everybody for choosing this course and hanging in there. I will see you next week. All right, have a good one.